Hello, in this video we'll be covering alternate approaches to BigO notation. Once again, if you are not familiar with upper bounds and lower bounds or sets, take a look at those videos earlier in this series. I will post a link in the description below. Firstly, BigO notation, as with all other asymptotic analysis notations, does not care about constants. So let's say you have these two equations, f of x equals 2x minus 6x plus 3, and g of x equals 5x, and we want to compare them. So if we want to know if f of x is big O of g of x, then we want to know if f of x is less than or equal to g of x. So firstly, as I mentioned, we can just ignore all of the constants. So first we'll simplify. 2x minus 6x is negative 4x plus 3. We don't care about this constant, and we don't care about this constant. So this is just x. And we want to know if x is less than or equal to 5x. Once again, we ignore the constant. That's x. X is equal to x, so this is true. Therefore, f of x is big O of g of x. Here's another example. We want to know if 3x plus 10,000x plus 5,000 is big O of g of x. And g of x is x squared. So first thing we do is f of x, we can just ignore all of the constants. We combine x plus x is 2x. We'll ignore that constant and just make it x. 5,000, it's a constant, we don't care about it. And we want to know if x is less than or equal to x squared. So we can just do some algebra and divide by x on both sides. This becomes 1. And we want to know if 1 is less than or equal to x. Any constant is less than or equal to any variable because, as I mentioned in the last video, we only are concerned with positive functions. So this would be the absolute value of x, and as long as x is greater than 1, then 1 is less than or equal to x. So it's just good to know that constants are always less than or equal to a variable. The one exception is trigonomic functions, non-exponential functions, non-polynomials, and that would be 1 versus cosine of x. Cosine of x, as we saw before, oscillates between 1 and 0. We'll cover some of these special cases in a later video in this series. For now, we'll just stick with basic polynomials and other exponential functions. After we've ignored the constants, another way of thinking of this problem is which equation is stronger. And to find out which equation is stronger, we will go to handy-dandy Wolfram Alpha and graph the two equations. Always from x from 0 to 10 is what I like to start with. Of course, you can always go larger. That doesn't hurt. And we can see that x squared easily overtakes x. It is larger. So, easy method of solving for big O, we simply ignore all constants. Then we solve for x. We divide where we can. We see if we can get some constant. Or we just compare the equations graphically and see which one comes out on top. In the next video, we'll be covering some more examples of asymptotic analysis, what's in big O of what else, etc. We'll also be comparing different families of functions and evaluating them against one another. So stay tuned. I'll see you next time.